Welcome to another video. In this particular video, we are going to talk about references and borrowing in Rust. Now, references and borrowing are integral concepts in Rust that work alongside with ownership, which we did in the last video, to ensure memory safety without the overhead of a garbage collector. Now, references allows you to refer to some value without taking ownership of it, which is especially useful for accessing data while still allowing the owner to remain the owner and eventually clean up the data. So let's look at references. Like a reference is created using the and symbol. You've probably seen that we've used it before, and it allows you to refer to the value of the variable without taking ownership. When the reference goes out of scope, it does not drop the value it points to because it does not own it. It's more like, you give someone your address but not your house. So you give an address to your house so they can use it, but they can't actually release it. It's under your ownership. So let's look at creating references. So go over here, say let's say s1 equal to string from, let's say, same stuff, hello. And now let's calculate the length of this particular string. I'm going to just call a function, call it calculate length. And to this, instead of passing the actual string because it will lose ownership, I'm going to just pass the reference to it. That's how you do it. And then I can say println, and inside this I can say the length of, let's say, whatever the string was is whatever the value is. And here I'm going to say s1 comma the length. And now let's go ahead and write that function calculate length, which takes s as an argument, but it doesn't have the actual string. It has the reference to the string, and it will give me back a use size, which is the size length of the string in this case. And I'm going to say s dot length. That's all I need to say. Let's run this, and you see the length of hello is 5. So what happens in here is we just pass the string address. It looks at the string, gets it length, and then gives it back, but it doesn't have the ownership of it. So in this example, s is the reference to s1. The function calculate length can use s to perform operations on s1, but it does not own it. After the function call, s1 is still valid because its scope is inside here. Now let's look at next look at mutable references. Now mutable references allow you to change the value you are referencing. However, Rust enforces a rule that you can have either one mutable reference or any number of immutable references to a particular piece of data in a particular scope, but not both. This rule prevents data races at compile time. Let's think about it. You are constantly changing the value in different places and it's referenced by different place, so that's what is called a data race during compile time. So let's look at creating a mutable reference. So in this case, whatever we have above here, let's use that. I'm going to say mutable s, let's call it s string from hello. Let's keep it that way. And here call a function change, and this function I will pass, usually you'll pass the string value like this, but in this case, since I'm passing mutable, you say mute in front of it. And now in your function change, some string that is passed, I'm gonna say mutable string here, and inside my function I'm gonna say some string dot push underscore string. You've used this before. Push this WRLD world. And so in this case, what happens is it passes that, and we change that string's value from hello to hello comma world, and you're passing a mutable instance of this. Now the rules of references at there are two of them. At any given time, you can have either one mutable reference or any number of immutable references to a piece of data, but not both. Now references must always be valid. Rust will not allow references to dangle. So it will just give you an error. And we'll look at one example about dangling references. Like Rust compiler ensures that references do not outlive the data they refer to, preventing dangling references. So let's look at an example. I can say function dangle. Now in this particular function, I am returning back string. So dangle returns back a string here. I'm going to go let s equal to string from and pass it hello. Now s is a new string in this case, and its scope is only this function, and I want to return that back to that. So what I'm doing is I'm not passing the string, I'm passing a reference to the string. And uh, what this Rust will do is it will give you an error saying that you can't pass a reference that will dangle your string. So hence s goes out of scope and is dropped. Its memory goes away, and the above code will not compile in Rust because it tries to return a reference to a variable s that goes out of scope at the end of the dangle function. This next thing that I want to cover about is slices. Slices let you reference a contiguous sequence of elements in a collection rather than the whole collection. So you can get a continuous sequence of elements instead of the entire collection. A slice is a kind of reference, so it does not have ownership. Let's look at slices look like. So I'm going to go here and get rid of these things. Let's say let s equal to string from hello world. Now in this case, if I just want hello inside a hello string and I just want the reference to it, so I can say s, but I don't want everything. I want 0 to 0, 1, 2, 3, 4, 5. So I just want hello. So that's what I'll do. Now if I want world in a different variable, I can say 6 to 11. And that will have world in there. Slices can also be applied to arrays. So for example, if I have an array of 1, 2, 3, 4, 5, and if I just want to get a slice of this array, I can say refer this array, and I just want 1, 2, 3, something like that. This code creates a slice that includes elements at indexes 1 and 2, but not 3, because if you want 3 then you'll probably have to do this, but this will just have 1 and 2 inside it. So you'll have 2 and 3 in this case, because the indexes of 2 and 3 is 1 and 2. It's a little confusing because of the way it's written, but that's how the slices work. Now references and borrowing, whatever we learned here, allows Rust programs to efficiently access data without taking ownership and without the risk of null pointers or dangling references. By enforcing rules around mutability and borrowing, Rust ensures safety and concurrency, making the code more reliable. Now, understanding these concepts is crucial for working effectively with Rust's ownership system, and we'll see a lot of these in our examples to follow. But if you have any questions, do let me know in my comments, and I'll get back to you as soon as possible.